Okay, so this question says, which of the following graph is the graph of h of x is equal to negative x squared minus 2x minus 2? And then we are also asked to prove, use math evidence to show that the point 0, negative 2 is the y-intercept of the quadratic function. So when we look at each of the graph, we want to think about what do we know about each of these graphs. When we look at A is opening upward and it has a y-intercept at 2. B is opening downward. It has a y-intercept at 0, 0. C is opening upward. It has a y-intercept of 0, 0. And D is opening downward and it has a y-intercept of negative 2. When we look at the equation that was given to us in the standard form, where we have ax squared plus bx plus c, well, the a in this case is equal to a negative 1, b was equal to negative 2, and c was equal to negative 2. So this tells us that our graph should open downward, right? Because that's negative. And or C is our y-intercept, it has to be crossing at negative 2. The only graph that opens downward and it has a y-intercept of negative 2 is graph D. So that's how we know that D is a graph that represents that function. Now, the second thing that we were asked to do is we're going to have to prove that the y-intercept is the point 0, negative 2. And so in order for us to do that, what we know when we're given a point on a graph is that the point should satisfy the equation. So our x value is 0 and our y value should be negative 2. And if when we plug this into our equation that is true, then the point is on the graph or it represents a function. So we're going to see if that is true. So we know that our x-intercepts, since the y-intercept occurs when x is equal to 0, we're going to replace x with 0 in the function. So we're going to actually find h of 0, which is going to be equal to negative 0 squared minus 2 times 0 minus 2. So h of 0 should be equal to 0 times anything is going to give us 0. And 0 does not carry a sign. Negative 2 times 0 is also 0. And then we're left with negative 2. 0 minus 0, that's 0. So h of 0 is equal to negative 2, which means our y value is negative 2. So what we just proved was that if when x is 0 or y is negative 2, so the point 0, negative 2 exists, and if it's the x is 0, it has to be the y-intercept of the function.